All right, welcome back. We're going to go over section 10.3 in this video, or at least part of it. And so we're going to be looking at a different conic section. We're going to look at the ellipse. So the ellipse is basically just an oval, and it could be, going this way. It could be wide, or it could be tall, depending on the equation and what all is involved with it. So let's go ahead and get the definitions and stuff filled in. We'll talk about it in general, and then we'll start to graph and all sorts of stuff. Okay, so an ellipse, the formal definition is it's a set of points, otherwise you wouldn't have a graph. So a set of points, the sum of whose distances from two fixed points is a constant. These fixed points are the focus points or the foci or the foci. So the major axis of an ellipse is a line containing the foci, and the minor axis is perpendicular to the major, and they intersect in the center. In the vertices, that's where the ellipse intersects the major axis. Some curriculum, they have co-vertices involved. We're not going to do those. So the vertices are what are the two outermost points that are the furthest away from the center. The other two, we don't really, I'm not going to have you label them. Okay, so let's see what the heck that definition was even talking about. So it's the sum of whose distances from two fixed points is a constant. So that means if you choose any point on the ellipse, you have two distances you can measure. You can measure the distance from this focus, and you can measure the distance from that focus. And it can be anywhere on this ellipse. So like if I chose this as my point, then I can measure two distances again. I can go from this point to the focus, and I can go from this point all the way over to that focus. So I've got a third distance and a fourth distance. So no matter where you are, you can always measure two distances. The thing that makes it an ellipse says that once you get done measuring, if you take those two distances, so if I added up D1 and D2, and then if I added up D3 and D4, the sum of those two distances are always going to be equal. And that's what sets it apart from other types of curves. That's kind of cool. Okay, so an ellipse, as I said before, it can go in one of two ways. It can be wide or it can be tall. So if the major axis is along the x-axis, so just kind of like this, or it's parallel, so it's been shifted up or down. So it's wider than it is tall. Your equation is going to look like this. It's got x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So there's a lot that's happening in this equation. X and y are on the same side. They're both in a fraction. They're both being squared. So there's a lot going on. So you know it's going to be wide or wider, because if you look at the denominators and compare them, the a is going to be larger than b. So the denominator under the x is going to be bigger than the denominator under the y. The center, figure out what makes both sets of parentheses equal to 0, so h and k. Then to get the vertices, you square root the denominator underneath x, and add and subtract that value from the center. And that would give you your two vertices. So if the ellipse is going the other direction, everything just sort of flip-flops. So if the major axis is along the y, or is parallel, your equation looks like this. Now, if you notice, it's the exact same equation. The book has the denominators flip-flopped, so they put the b squared underneath the x and the a squared underneath that, and so what that does is it kind of flips everything, and to me, I like it to be consistent. I don't like to change the equation around if I don't have to. So you can keep it totally the same, and it's not going to matter. If you were taught to put them as different, that's fine too. I don't care how you do this. It's not going to hurt my feelings if you do something else. But I like it when it's the same, because I can still compare my denominators. If the denominator underneath the y is bigger, I know it's going to be a tall ellipse. I can get the center in the exact same way and the vertices kind of in the exact same way as that, whereas before. Just square root what's under the y's and add and subtract it to the y value of the center. Okay, so that's a good intro to an ellipse. In the next video, we're going to start graphing them, and then eventually we're going to go backwards. We'll get the equation of what an ellipse is going to look like.